Welcome to AI Snacks with Romy and Robbie, your bite-sized journey into the fascinating world of artificial intelligence. I'm your host, Anastassia, CEO and founder of AI Edutainment, an AI literacy company from Switzerland that brings the knowledge and understanding of AI and robotics into 1 million families and 100,000 companies globally. And I am so happy to host today Sairam Sundaresan. After getting his master's degree from the University of Michigan, Sairam worked for 8 years at Qualcomm on groundbreaking computer vision and machine learning projects for multimedia applications. His work is in our smartphones, and he worked on real-time 3D reconstruction. This work was featured in Forbes. He developed cutting-edge object tracking algorithms, and he has dozens of patents and publications. But beyond this, Sairam is an educator at heart. He has served as a machine learning lead and mentor at the Frontier Development Lab for 3 years, and the work of his team was mentioned by Google CEO Sundar Pichai. Sairam became globally recognized as an educator through his Gradient Ascent newsletter and his book, AI for the Rest of Us. He makes complex AI ideas accessible to non-technical audiences. And of course, we are putting all the information into the show notes of this podcast. So in this episode, Sairam and myself are exploring a question that sounds almost uncomfortably human. What is really inside large language models, and can an LLM lie to its creators? So we will take you inside the mind of modern large language models, and we will change maybe how you think about reality, truth, intent, and even responsibility in the age of intelligent machines. Let me now welcome Sairam into the studio, and thank you for tuning in. Sairam, welcome to my studio. I'm really excited, and you're really the first guest on my podcast who is tuning in from India.
Delighted to be here and also to be the first guest from India. That's a big honor. So thank you for having me.
Absolutely. And where are you based there?
I'm based in the southeast of India in a city called Chennai. It's one of the biggest cities in India.
Yeah, I have quite a memorable story about Chennai because, back in 2009, 2010, I visited Chennai because there was a huge Nokia factory there.
Yes.
And it was quite funny because, I did not want people to know that I am from Deutsche Telekom, one of the largest customers of Nokia. And I was with someone from India, and he simply said at the registration desk, she's a VIP, and she's so important, we can't really disclose her name.
Wow,
and they said, okay. And I walked in, I could ask every question I wanted, and I could look into everything. And the following week, I was visiting China, and frankly, they were screening me from my shoes to my head. Probably they know all my sizes. So nothing was really allowed. They were following me everywhere. And I was asking questions, and they are at some point in time, very interesting questions. We are going to show you our real factory. Is this one fake? They say, yeah, it's just a proxy for tourists. And then we were driving for 3 hours, and in the middle of nowhere, there was a high-tech factory. But this one in Chennai was remarkable because in every single hall, there was some kind of a German or Austrian or Swiss machine. And it was like in the middle of the 21st century from the technology perspective, very modern, and still this incident on the registration desk. I really love the story.
It's a fascinating story for sure. And by default, India is a very warm and welcoming country. So I'm not surprised.
Absolutely. So, Sairam, you're so versatile. We can discuss everything from hardware and semiconductors to agents, etc. But my audience is really struggling with the understanding of LLMs. And let's just focus in this episode on discussing what are those beasts in technology, what are they doing?
Sure.
And are those rumors correct that they are lying to their creators? So let's just deep dive into large language models. And let me ask you not a quite a simple question, but quite a big one. For someone who has never worked in technology, who is not a computer scientist, who is not a statistician, what is actually inside of a large language model? And could you please guide us through the components? Maybe you will talk about what is an attention head. What are those beast transformers? Why they were discovered, let's say, not from the initiation of deep learning, but later. So
Mhm.
everything you can tell us, and please bear in mind that my audience is not technical.
Okay, so that's definitely a big question and a very interesting one. I'll do my best. So first of all, an LLM is something is a class of something called a neural network. A neural network is an algorithm that is loosely inspired by the human brain. And the human brain, we have several neurons, and each neuron is interconnected to other neurons. They communicate, and we can do a whole lot of fascinating things, right? That we learn and we are able to repeat. Now, in a neural network, you have their artificial counterparts where they learn from examples, and by showing tens of thousands, in some cases millions of examples, they can then learn to do a similar task by learning patterns. So an LLM is just a class of this neural network. So you can think of it like a factory where some kind of set of items go in, and the next item that's supposed to follow these set of items comes out. So that's what the factory produces. So inside the factory there are several moving parts. We'll get to them in a second, but at a big picture level, you can just think of it as a very sophisticated autocomplete. It's kind of insulting to call LLMs autocompletes at this point of time given everything they do, but it's a good mental model to start with. Now, having said that, so how do they know what comes next? The answer for that is that they learn from patterns from millions of examples, as I said before. So, you, for example, if you take text, you have several books, you have Wikipedia, you have all kinds of things on the internet where, these models can then learn from this text. It can learn to fill in the blanks. Basically, it can part of teaching these models how to predict the next thing that comes in a sequence, we can just remove some items from a block of text and then say, can you guess what comes next? What do you think should follow this set of words? Or do you think that this particular sentence is a logical follow up for the sentence? And by giving it a lot of exercises like this over and over again, the model then understands patterns in language and then is able to then synthesize or predict what comes next based on what you give it. So that is a very high level breakdown. If you'd like, we can go deeper, but I just want to pause for any questions or if something wasn't clear.
Tell us, please, about one thing.
Mhm.
So the language processing started actually in the 50s and in the 60s. Why did why did it take so long for such models to become so fluent that they can truly mimic, let's say, what humans are doing since the inception of the language?
Sure. So I think this might be true for all of neural networks in general across domains, not just language. I also feel that if you look at, say, vision and other modalities, we still have this big gap between when the process of working with these modalities started and now this big boom where we're able to just about do anything with these networks. So it was, I think, around 2012 when this deep learning revolution took off. And for those who are wondering what deep learning is, it's just the field that builds neural networks that have very many layers that are stacked together. So imagine that a neural network has a few artificial neurons connected to one another, maybe tens or hundreds of artificial neurons connected together. A deep neural network, on the other hand, has thousands or millions, and in modern cases, even billions of these neurons connected together. So deep is not from any philosophical point of view, it is more from just the sheer size of these models. So, first of all, these algorithms existed before 2012, and I think like the source of all neural network designs, the perceptron, was invented in the 40s, 90s, if I'm not mistaken. But what happened crucially is, first of all, we had a large volume of data finally available. You can think of the known internet, how many Wikipedia articles, blogs, news pages, and pretty much you can think of how many books were available online and research papers. All of this suddenly increased the amount of data that was available for these models to learn. And then the next aspect is you had compute power available. Prior to this, GPUs or graphical processing units were only used for rendering activities. Like you can think your fancy special effects in movies, or for gaming, where they used to render very complex scenes. Researchers discovered that the same calculations that could be used for rendering these scenes in games or special effects in movies could now be actually used for making the calculations within a neural network much faster. These calculations are called matrix multiplications, for those who wonder. But GPUs allowed people to parallelize, meaning they could run hundreds of thousands of matrix multiplications in parallel, while this in turn reduced the time it would take for you to get results or train these models. Now you have the data available, now you have the GPUs available, and then you finally had the algorithms available. So in 2012, for the very first time, we found that this explosion took place where a model called AlexNet, named after one of the inventors of that network, beat the previous state of the art by almost 11 or 15% in a image classification competition. Now you just extrapolate that over to language, you suddenly had this vast corpus of data. You had the compute power necessary to train models that could truly extract meaningful patterns at scale from this data, and you had the algorithms available. You just that had to be a little bit more of research done. For example, the transformer that came out in 2017, for us to get to the point where we're all of a sudden doing things that we previously scarcely expected would happen. So that's my take.
And still, I mean, the industry is quite surprised how well those transformers are functioning. And, you know, I'm actually, I like that you're talking about a very sophisticated autocomplete because, sometimes the perception and the general perception is that we are at the very beginning of the nascent AGI.
Mhm.
And I'm always asking why out of sudden. Yes, it's a very sophisticated processing. It's statistical processing of tokens. And token might be whatsoever. It might be a piece of a word, but it might be a sound. It might be some financial figure, right? It's not necessarily about the language. And those transformers don't really understand in a human or in a biological sense of the word understanding that they're dealing with the language. But I'm quite curious. So they are tremendously powerful, and I'm using them to help my disorder, to organize what I have in terms of files, and to really streamline my buckets of content. I produce tons of content.
Mm.
Imagine you have a small business owner in front of you, and this business owner is trying to figure out, how can I use LLMs for myself? Do I need to be connected to a huge data center? Do I need to be a Lonza or Siemens to work with this technology? Will it somehow um, completely screw up my local network if I start using um, ChatGPT or Claude for very rudimentary tasks? And do I need to study Python in order to actually utilize it to whatever I am doing? Streamlining my inventory, helping me organizing my content, maybe doing some pieces of my legal work, so something which is really standardized. So how would you coach such a small business owner in terms of usage of LLMs?
So I think that's an interesting question, depending on the use case. So when we say small business owner, can, as you said, can be any number of things. For a lot of things where it's about organizing things or brainstorming or writing or drafting, it's always easier to use what's already available. So you can just use your favorite LLM of choice. I won't pick one because every release, one particular LLM provider suddenly, beats all the benchmarks, and benchmarks are, they're debatable. Let's just say that. So just pick the LLM that you typically work with, and first do an audit of your workflow. I would actually suggest just manually write down the steps that you take to go from start to finish of a particular workflow. And once you've done that, actually just see which parts you can then prompt an LLM to do for you and just see how it does. So, for example, if it's organizing files, for example, there are two things that come to mind. One is the more recent release from Claude. I think it's called Cowork, that works locally on your desktop. Again, permissions, safety, privacy, all of those are valid concerns. We'll get to that. But just as an example, that's a good way for you to get started with organizing things. If it's writing content, then you can give it maybe 10 or 15 examples of your style of writing, like previously successful posts that you have published on a certain social media platform, and then ask it to understand the patterns from there. Because it has seen tons of text before and you have given it examples to learn from, it can then identify what makes your writing sound like you, and then it can then help you brainstorm and create new types of content that are very similar. They may not be perfect, and you would have to iterate a bit back and forth to produce the output that you are comfortable with posting on social media, for example. Then there's the other line of content, which is actually working with files, working with code, or building things that will help you manage your business. For that, there's this next class of tools. So if you don't come from a programming background, if you are a non-tech small business owner, is you have personally, I'm a huge Claude Code fan. If you get past the initial uh, fear of using a terminal, it's actually very easy, because the barrier the that previously existed was you needed to know how to write code, understand code. But now there is the ability to converse with these models with language. And then, yes, you may not get production level code, but if your use case doesn't demand it, if what you're trying to do is automate away things that help you streamline your workflow, give you back time to focus on the business versus the grunt work, that's taking you away from it, that's a win-win. If you aren't quite there yet, the next level of abstraction is like these no code tools. You have like Lovable, you have Bolt, Replit. I think there are a few tools which you can just give them a brief in language, and then they'll work something up. Those are great for people who are like absolutely bare beginners, but if you want customization, it's probably that's where the Claude codes and the cursors of this world are actually useful for. So I would actually think about auditing all the things you do as a business owner. Which of these are non-technical from the perspective like content creation or organizing files, or things that don't really require you to work with files and code, or something that needs coding. Keep those in one bucket, your technical stuff in another bucket. And then for each of these workflows, just go start to finish. What do I do if I am manually doing this on a daily basis, or if my employee or intern or somebody is doing this, how are they doing it? Document that. Then incrementally add LLMs, just to see how they do the task, and see if you can coach them through prompts and examples to accomplish that task. And so slowly, one by one, you identify two things: one, where an LLM can help you, and two, where it's probably not a good idea. And doing this over a large number of tasks in your business actually allows you to automate away a ton of stuff. I'm not going to get into agents just yet, because
Yeah.
I just want to keep it very, very simple.
No, and thank you for that. And your newsletter, and we will post information about your newsletter to the show notes, is a great source to learn about the how behind quite simple things. And by the way, GitHub is quite a nice space to educate yourself about technology, to try things out, to ask questions. So this is quite a nice community. And I am wondering now about one issue. I would love to address the fear. And so many people are reading all kind of books, or the media coverage of AI is sometimes all about angst instead of all about the opportunity. And without really overhyping the opportunity, let's look into the danger to
Hmm.
utilize LLMs. And there is quite a prominent slogan that those LLMs are so sophisticated. They are even evolving into something which is kind of semi-conscious, and they start deceiving the creators. So there is this ongoing concern that LLMs lie to the trainers or to the developers. And could you briefly talk about this phenomenon? Maybe give us a couple of cases, examples where that was the issue, and how is this lying, so-called lying, different from hallucinations?
So, first of all, hallucinations are a feature of LLMs, not a bug. So, as
Okay, tell
as
me.
as we as we discussed at the start,
Yeah.
language models are guessing or predicting what is the statistically most likely thing to follow a set of items. Now, the set of items are words. Next most likely word is what it guesses or predicts. If the set of items are pixels, it predicts pixels. So it's
Mhm.
not really, at least in my opinion, it's not really thinking like you or I do. Rather, it's guessing, and so therefore, hallucination is a feature. It's not a
Yeah.
bug.
Yeah.
It's how these models are trained, and therefore, it's how these models are producing output. So, which
By the
means
way,
that
this I'm completely with you on that one. And this is, for example, why I consider some regulation to be frankly nonsense, because you can't regulate the basic maths and the foundation of those models, right? I mean, yes, you can debias all the way you want, but if the system is not capable to do a distribution shift, like, let's say, biological brains are doing, it will always hallucinate. You can tweak certain things, of course, but you will not remove the basic issue from the architecture. And we need to move somewhere else to eliminate this feature from being a feature.
yeah, and which is sort of like, it should be like a warning on the shipping label of most LLMs,
Yeah.
and it is, right. Like any LLM provider, they always say it can make mistakes. Please, verify, and then they have like an entire disclaimer which you can go and read, which is true, right? I mean, for factual tasks, you're better off not trusting them, because sometimes they can hallucinate things that sound incredibly confident, but when you sort of probe a little bit more, you find that it's full of holes, and it's not really true. And it's a function of what they're trained on. If it's not part of their training data set, uh, it's very difficult for a model to give you verifiable information, or verified information, I should say. Now, coming to the lying aspect, I don't have too much on that, but I do remember reading about this particular case where, as an experiment, I think some researchers gave an LLM some context that an employee was doing some unscrupulous activity, and then in another unrelated document, they basically said that they're going to replace this LLM with another model because of costs or whatever. And this was the employee who was doing the unscrupulous activities was the person in charge. And the story goes that the LLM began to threaten that employee that their secrets of whatever that activity was would be leaked to the entire company, or something. So this is very difficult to unpack personally for me, because one, wow. Two, if I think about the number of stories it's read, like the fiction stories, and it's read crime novels, probably it's read espionage, all kinds of information in its training data. I'm sure there's like some pattern matching there that allows it to connect the webs in the way it has. But is it lying on purpose? That's certainly something that's beyond me at this point of time, where I can't add anything of truth, because the only people who would know are the folks who are actually training these models at scale. And even then, if you think about it, they are adding a significant number of guardrails to make sure the models don't produce behavior that is harmful to any of their users. I'm sure that, I think, was it a few years ago when some chatbot was released, and it just started spewing very toxic content, and then was immediately shut
Yes.
down. I don't remember
Yes, it was
which.
Microsoft
Yeah,
chatbot. Out of sudden, it transformed itself into some neo-Nazi, and within a day
right,
started putting out slogans which were beyond, and it's like, what type of a community did it interact with?
right.
It was,
So,
yeah.
so to me, this shows that what you train an LLM on, si- you know, gives you a scope of what it can and can't do. Because if your training data is full of toxic, biased, harmful information, your LLM is not going to be helpful or good. It is going to be biased and toxic in that same way. And so this is where the entire notion of the regulation, we have to focus on the data, right? Is the data helpful or harmful? Is it biased? What are the biases that we are unaware of? Because it's very easy for us humans to miss corner cases, and we usually catch them later in production, which is fine. I mean, it's to err as human. For me, that lying and all of those aspects, I think I would much more focus on the data side of things, because I feel that's where they stem from. And like you said, these are mathematical operations that we're doing based on the data. So models knowledge is basically a bunch of weights. It's a bunch of numbers. And to then somehow, it just sounds like incredible for me to think that a model can intentionally lie. But then again, I don't have much more context than the powers that be to answer this beyond that.
No, and I'm very grateful because I mean you're a technologist and you are building things so every day. And whenever I read, so those models were put under pressure. Which pressure? I mean, what does it mean to exercise pressure on a piece of code? We are
Yes.
not in a human conflict situation where everyone is yelling at each other, right? We are not at war. So what does it mean to exercise pressure? And in terms of, hallucinations, so one of my favorite stories is actually a tweet by Jan LeCun.
Hmm.
Jan was giving a public lecture. So I think it was March 2023. And after this public lecture, a lady approached him and she said, "Oh, really, I use ChatGPT. I love it. And I use it to write horoscopes." And his answer was, "This is a perfect use case."
Okay.
Because it will lie its way out of the prompt. And I actually love what you were saying. Where is this thing taking the data? And I'm kind of, okay, so if we are imagining the semantical space and vectors, shifting stuff. So what type of a semantical space is out there to human word seduce the model to lie?
Right.
Yeah.
Right. That's the real question for me. I mean, I would
Yeah.
look at the data
Yeah,
and start from there.
absolutely. Absolutely. I am wondering about one aspect, and I'm following this, I'm learning about this really weekly now. I'm quite a fan of embedding ontologies into LLMs, and those ontologies represent, let's say, some particular knowledge, for example, of medicine or of physics or of whatsoever. And this is kind of, a hybrid approach to build LLMs. Part is from the artificial neural networks, and part is from what used to be called symbolistic AI.
Mhm.
So are you following the space around ontologies, and what is your opinion on that?
I am not. I'll be very honest. But it's certainly a field I think I would like to keep a pulse on going forward. I mean, if you would mind sharing a few snippets from there, I'd love to understand that.
Absolutely. So I will connect you even to some people who are working on this. But, for me, this is the only path which can somehow bring to more general AI and actually allow, if there are multiple ontologies, multiple fields, that will allow more causality and understanding within these models. But how do you explain those claims that LLMs will bring AGI at some point in time and all the investments into those gigantic data centers and everything? Do you think it's kind of, based in we've invested so much and now we need to justify it, or what is behind it?
So once again, I'm probably not the most qualified person to answer this, but I will give you what I have in mind. So first of all, I don't understand what AGI would look like personally.
Yeah.
Because if I just look around today and see what I can do with the tools that already exist, it blows my mind.
Yes.
Just from 3 years ago to now, the sheer amount of work that I can get done to a high level of satisfaction with these models is mind boggling to me. And even if we did nothing else for the next few years, I still think that we could do a ton of innovation in a number of fields using the models that are available at our disposal. So for me, the notion of what AGI would even look like is very amorphous. I don't have a clear picture of what it would look like. So having said that, my gut feeling here is that when they were training these models at scale, initially, I think they started noticing what people called emergent behavior, which is they started seeing these models doing really well on tasks for which they weren't explicitly trained on. And so the thought process goes that if we start scaling these models with more data, making these models larger and larger, then more and more of this general intelligence should appear. Now, there are different camps of people who, one, feel LLMs are the solution, and two, do not feel LLMs are the solution. And I don't have a stake in either of those camps yet because I don't have the full picture. That's where I am. However, the need for these data centers is arising from this need to make these models bigger, to add more data, and to train these models at scale, which is a Herculean task. And only a few of the biggest labs in the world can afford to do this and can do this successfully at scale, because training these models at scale is almost like a secret recipe that nobody publishes. And so you need to have the best talent, you need to have the largest infrastructure available to support you, and then you just train and see what happens. And so for me, that's my worldview at this point of time. I don't have a picture of what AGI would look like, whether it's necessary, or even how we would get
Frankly, I wonder whether it's really necessary. I'm in the second camp, so I am not with like LLMs will bring AGI upon us, because I fundamentally believe that real intelligence requires causality. And current LLMs have no embedded causality. So there is Judea Pearl and others researching causality. There is nothing in the computation against the causality,
it.
but the money is kind of, flowing into the traditional scaling piece. And maybe just, to end this podcast, but to ask you a very important question about synthetics. So there are some claims that we are running out of data
Hmm.
worldwide. So we are running out of language, and for different reasons. First, the scarcity, and then obviously you can't touch every piece of data due to regulations, or simply difficulties to get to this piece of data. How do you think about synthetics? And do you think that synthetics are bringing a particular set of problems to developing technology solutions?
It's an interesting question. One example that comes to mind, I think it was this model called Lava that first used synthetic data to successfully train a model. I think they used a text only GPT model to generate descriptions of a very large image data set and then build a multimodal model Lava on top of it. So it can work, and we have seen it work fairly successfully. And then there was an offshoot of it for medical use cases, which I think also gained a lot of spotlight. But to answer your question, yes, we are running out of data by the looks of it. And we can already see the internet being flooded with LLM or AI generated data. And what worries me in this is actually what is going to be our source of truth going forward. Because if you think about how like previously, if you ask an LLM to cite its sources, this is before the LLM started flooding the internet with slop and with also seemingly accurate information. You had this notion of, okay, if the source comes from Wikipedia or if it's from this particular blog, it's going to be more or less reliable. But now the amount of fact checking you have to do, because the LLMs are now
Yeah.
citing LLM generated sources, and it's very hard for us to know which is actually true. So are we really rewriting what is true and what is not? And are we actually you know if that happens, then does that mean that synthetic data will be enough, like we can just keep generating stuff? Those are the interconnected pieces of thought. So your question was like, what is the value of synthetic data? I feel like it has value if it is curated with domain experts in the loop, because we can't create data at scale, not at least the scale at which these models are consuming them. So part of how these models will need to evolve is for us to be able to generate synthetic data that is verifiable, that has some way of fact checking, and that comes from having a domain expert being, or domain experts being leveraged to verify based on their experience, based on actual scientific research and so on. So for me, there's use cases where I feel like synthetic data will be very helpful. Like there's this instruction type of tasks for which, yes, you can get away with a lot of things. But if it's like scientific or factual things that you need to use these LLMs for, that's where I see the gap.
Yeah, and I really wonder, because I was for a number of years on the board of Dun and Bradstreet, which is the enterprise data company. And one of the things DNB was doing back then was really, does this enterprise exist? Is this a real executive, or is it, let's say, a
Wow.
fake executive? I mean, of course, if you need to, let's say, partner with someone and this partner sits in another corner of the world, how do you know? As a
Mm,
small business, I'm not talking Siemenses and Novartises with tons of
right.
lawyers and all the expertise. So, and I am just wondering whether they might be valuable businesses tracking the sources of data and tracking whether the data was a product of LLM imagination. So once again, a human word to something technical, and how to actually build the library of the real data versus the fake data. Because frankly, so we have so many articles about fake publications and scientists quoting sources which have never been written.
Yeah.
Maybe LLMs are writing some articles which have never been from human beings and never been checked or peer reviewed. And I can foresee a business of, human, non human, with all the pros in favor of utilizing synthetics for one or another thing, because current technologies require big data in some aspect or in another. So we will see.
There's just a couple of points I'd like to add there. So the first one is, in addition to what you said, the other thing is, if errors exist in that synthetically generated data, this is a way to amplify it. If you are generating synthetic data, training these models, then more models believe this is true, and error amplifies. And if there's biases in the data, again, another way to amplify it. And you'll also see that a lot of these models kind of output text in the same way. It's come to the point where most people who have interacted with LLMs know when a text is LLM generated. Like, there are certain tells which are very easy, so that diversity of language, like how you or I would write the same idea, it would be completely different if let's imagine a world where we wrote it on paper without using any LLMs. We would write it in different ways, explaining the same thing. That diversity is reducing, in my opinion. And connecting it, like, you might ask, so why should we employ humans and domain experts to create more data to train these models? Yes, and it also is important on the lines that you mentioned, which is that we have to give this sense of authenticity, or a way to track the creator of the data, because they need to be compensated. Because at the end of the day, the thing I'm seeing a lot is, especially in the creative arts, I'm seeing a lot of people who've built like 15, 20 years of experience and built a signature style, a way of producing art or other things, their work just being mass manufactured now with a prompt, and they aren't being compensated as far as I'm aware. And that has to change if we want richer data available to us for empowering people in the right way. Then the people who create that data need to be compensated fairly. There's no two ways about it. So just wanted to add that.
No, and I applaud this. I mean, I am a writer, so I write those AI books for children and for their families, of course. And it's a difficult one because we are in a transition period, and I assume that there will be a new notion of what does it mean human quality in the written word. And it's not just about communication and providing some information. It's about why do humans write?
Hmm.
Which is a very big philosophical question. Sairam, I can't really be more grateful. Thank you so much for all your insights. I would like to ask you last question. If you had a magical wand and you would wish for maybe one or two things in AI to happen in the next 24 months, what would those two things be?
First one, I would definitely say AI models finding cures for very difficult and incurable diseases. That would be my first wish. Second wish is for AI models that run energy efficiently, so that we take better care of our planet. So if we could do those two things with that magic wand, I'd be delighted.
Well, I really would love to hug you now, but I'm in another part of the world. Thank you so much for this. And I must admit, so many people, so many AI developers are just wonderful human beings who are thinking about big life things, which have nothing to do with the technology itself. But I think that this vision to help the planet and to help human beings to facilitate science, this is quite a big one. And for this, collaboration matters. And thank you so much once again for coming on this podcast, for talking to me. I will provide all your information in the show notes, and best of luck and best of success in the upcoming months and upcoming years. Thank you.
My pleasure. Thank you so much for having me once again.
Thank you. And that's all for today's AI snack. We've just peeked inside the fascinating inner world of large language models and how they turn patterns into words and words into meaning. If this sparked your curiosity, make sure to visit AI Edutainment website, where you'll find our latest blog explaining how small businesses can start using language technologies to work smarter and save time. And I decided to make our journey even more practical. Starting with the next episode, I'll share one or another concrete idea for implementing AI in small and mid-sized businesses. So stay tuned until the very end of each episode and don't miss the closing insights. If you enjoy what we do, please support the show, subscribe, share this episode with family and friends, and check out the Romy and Robbie book series for fun way to explore AI together. Thanks for listening, and see you next week.